Good day, everyone. I am John Brian Almazan, presenting to you the digital subscriber line and broadband technologies. So, DSL stands for Digital Subscriber Line. It is a family of technology that are used to transmit digital data over telephone lines. In telecommunication marketing, it is widely understood to mean asymmetric digital subscriber line or ADSL, which is the most commonly installed DSL technology. So the family of digital subscriber line includes ADSL, RADSL, HDSL, IDSL, SDSL, and VDSL. Asymmetric digital subscriber line is also known as ADSL, which is a type of DSL technology. It is a data communications technology that enables faster data transmission over copper telephone lines than a conventional voice band modem. In ADSL, the bandwidth and bitrate are said to be asymmetric, meaning greater towards the customer premises downstream than the reverse upstream. Providers usually market ADSL as an internet access service primarily for downloading contents from the internet, but not for serving content accessed by others. ADSL works by using spectrum above the band used by voice telephone calls. With a DSL filter, the frequency bands are isolated, permitting a single telephone line to be used for ADSL service and telephone call at the same time. In these current times, most ADSL communication is full duplex. Full duplex ADSL communication is usually achieved on a wire pair by either frequency division duplex, echo cancelling duplex, or time division duplex. ADSL supports a range of asymmetric data speeds that can reach up to 7 Mbps downstream and 1.5 Mbps upstream. ADSL can deliver simultaneous high-speed data and telephone service over the same line. The next one is Rate Adaptive Digital Subscriber Line, which also known as RADSL. It is a pre-standard asymmetric digital subscriber line solution. It supports downstream data rates for up to approximately 8 Mbps and an upstream data rates of up to approximately 1 Mbps. RADSL allows rate adaptation while the connection is in operation. Rate adaptation during connection setup is possible in many other DSL variants, including G.DMT and its successor. Rate adaptation while the connection is in operation is specified as an option in ADSL2, ADSL2 Plus, and VDSL2 under the name Seamless Rate Adaptation (SRA). The next one is High Bitrate Digital Subscriber Line, which is also known as HDSL. It is a telecommunication protocol standardized in 1994. It was the first DSL technology to use a higher frequency spectrum over copper twisted pair cables. It was developed to transport DS1 services at 1.544 Mbps and 2.048 Mbps over telephone local loops without a need for repeaters. HDSL provides a symmetric connection, that is, upstream speeds and downstream speeds are the same, at the distance of 12,000 to 15,000 feet. Symmetric connections are more useful in applications like video conferencing, where data sent upstream is as heavy as data sent downstream. The next one is ISDN Digital Subscriber Line, or also known as ISDN DSL or IDSL. It uses ISDN-based digital subscriber line technology to provide a data communication channel across existing copper telephone lines at a rate of 144 kbps which is slightly higher than a banded dual-channel ISDN connection at 128 kbps. IDSL uses the ISDN grade loop without basic rate interface in ISDN transmission mode. The benefits of IDSL over ISDN are that IDSL provides always-on connection and transmit data via a data network rather than the carrier's voice network. The next one is Symmetric Digital Subscriber Line, also known as SDSL. It is a digital subscriber line that transmits digital data over the copper wire of the telephone network. The bandwidth in the downstream direction from the network of the subscriber is identical to the bandwidth in the upstream direction, hence symmetrical identity. This symmetric bandwidth can be considered the opposite of the asymmetric bandwidth offered by ADSL technologies, where the upstream bandwidth is lower than the downstream bandwidth. SDSL is generally marketed at business customers, while ADSL is marketed at private as well as business customers. The last one is Very High Speed Digital Subscriber Line, also known as VDSL. Both VDSL and VDSL2 are digital subscriber line technologies providing data transmission faster than asymmetric digital subscriber line. It offers speed up to 52 Mbps downstream and 16 Mbps upstream over a single flat untwisted or twisted pair of copper wires using frequency band from 25 kHz to 12 MHz. These rates mean that VDSL is capable of supporting applications such as high-definition television as well as telephone services and general internet access over a single connection. VDSL is deployed over existing wiring used for analog telephone service and lower-speed DSL connections. According to Encyclopedia, broadband technology refers to a high-speed, higher bandwidth connection to the internet than is offered by a standard telephone line. The greater the bandwidth of broadband connection allows for more data to be transmitted at higher speeds than the conventional telephone line. So the broadband technologies that we use nowadays includes DSL, cable, fiber optics, satellite, and BPL. DSL is a technology delivered via wireline transmission which transfers information faster through conventional telephone lines made of copper that most homes and businesses already have installed. DSL-based broadband supplies data transmission rates varying from a few hundred kbps to million bits per second. The accessibility and rate of speed of your DSL connection depends on the distance from the residence or company to the nearest phone company center. The next one is cable. The cable connection is supplied by the regional cable television company. With this type of service, the cable connection's speed differs based upon the quantity of consumer using services during a particular time frame. In a distinct geographical location, end users of the broadband cable services share the connection. This can impede the speed based upon the number of consumers using the system at one time. The next one is fiber optics. Fiber optics technologies changes electrical signals, moving data to light and transferring the light by way of translucent glass fibers, measuring about the width of a human hair. Fiber transfer information at velocities in excess of present DSL or cable modem speeds, generally by tens or hundreds of megabits per second. The real speed encountered fluctuates dependent on an assortment of variables, such as how near to your PC the services provider installed the fiber, and how the services supplier configures the platform, including the volume of the bandwidth utilized. The next one is satellite. The slowest broadband service is supplied via satellite. Despite the fact that this is an excellent substitute for dial-up for individuals and businesses in remote rural locations, the setup fees are normally higher, but the monthly subscription expenses are similar to the two other options, cable and DSL. So the last one is BPL or broadband over power line. BPL is the distribution of broadband services using current low voltage and medium voltage electrical power distribution grid. Broadband over power line speeds are similar to the digital subscriber line or DSL and cable modem speed. It can be offered to residences employing present electrical connection and electrical outlets. BPL is a developing technology which is accessible in very few areas. It has substantial upside potential since power lines are virtually throughout the globe, thereby eliminating the requirement to construct new broadband service centers for each end user. So these are the references that was used in the discussion. So that concludes my presentation. Once again, I'm John Brian Almazan. Thank you.